In this video, we're going to talk about a related rate example. In this example, we've just got an equation, x squared plus y equals 1/2 xy, and they tell us if dy dt equals 2 and x equals 10, then find dx dt. So this really isn't a full-blown related rate example that comes from some physical situation, although the parts of it, once you find the equation, are pretty similar. So this is just kind of a warm-up really for the related rate problems. Okay, so I have an equation here, and I'm assuming that x is a function of t and y is a function of t, and I don't really know what they are. So I'm going to have to take the derivative implicitly. Okay, so I'm going to go ahead and do that and explain how that goes here. So first off, when I go to take the derivative of the left-hand side, right, I have the sum of two functions, x squared plus y. So by the sum rule for derivatives, all I have to do is take the derivative of x squared, right, and then add the derivative of y. So the derivative of x squared, right, is 2x by the power rule. But again, remember the assumption here and on these related rate problems is that all of the variables are functions of time. They change over time, and we don't really know what the rule is. So x really here is taking the place, it's covering up some more complicated function that we don't know what it is. So all of these derivatives really are chain rule derivatives. So it's really not just 2x. That's going to be the derivative of the outside and leaving the inside part alone. But then we have to complete the chain rule, right? The chain rule says the third part, multiply by the derivative of the inside part. So we don't know what that formula is, but we can have a symbol right here that says, hey, if you ever find out what x is as a function of t, then take that derivative and put it right here. Okay, so that's the derivative of x squared is 2x dx dt. Then I'm going to put a plus according to the chain rule, the sum rule, and now I'm going to take the derivative of y. Well, again, y is some function of t that I don't know what it is, right? And so I'm just going to put the symbol here. If you know what y is as a function of t, take its derivative. Otherwise, I'm just going to put dy dt here as sort of a placeholder for that. Okay, so that is the derivative of the left-hand side. Then I'm going to put the equal sign, and then I'm going to take the derivative of the right-hand side. Well, the right-hand side has a constant, 1/2, right, times some function, x and y. So I'm going to use the constant multiple rule. The constant multiple rule says, hey, if you have a constant times a function and you want to take the derivative of that, just rewrite the constant, which is what I did, and now multiply by the derivative of the function part. So to complete this derivative, all I have to do is to multiply by the derivative of x times y. Well, x times y, right, is a product of two functions. Remember, x is some function of t, I don't know what it is, and y is some function of t, I don't know what it is, but I'm multiplying those two together. So I have to use the product rule to take the derivative. Okay, so first off, I'm going to take the derivative of x with respect to t. Again, I don't know what that is, so I'm going to put dx dt for the derivative, and then the product rule says leave the other one alone, so I just left y alone. Then the product rule says put a plus, and then reverse that process. The first time around I took x, the derivative of x. This time I'm leaving x alone. And then the first time around I left y alone, so now I'm going to multiply by the derivative of y, which all I can say at this point is it's dy dt. Okay, because I don't have the explicit formula for y, but whatever it is, just take its derivative and put it there. Okay, so that completes the derivative. I've taken the derivative implicitly right here. And just like in the full-blown related rate problems, I've got some things that I know and an unknown. So here the unknown is dx dt. That's what I'm going to be trying to figure out. Okay, I know that dy dt is equal to 2, right? So I can plug that right in there. And I know that x is equal to 10, so I can plug that right in there. Okay, and then solve for dy dt. There's just one catch, right? And that is, well, they never gave us what y was, right? If you look back up here at the statement of the problem, they never tell us what y is. Okay, So there is a way that you can figure that out, right? And we have this relationship here with x and y. Okay, so what we can do is, well, we know x is 10. We can plug 10 in for x into this equation that only has x's and y's in it and figure out what y is first. So let's do that. All right, so we're going to take our formula and we are going to plug in a 10 over here, and then we're going to simplify this out. 10 squared is 100. 10 times a half is 5. So we get that. Then solve for y. We subtract y from both sides and then divide both sides by 4, and we get y equals 25. Okay, so we figured out what y was. And so now we have that dy dt is 2, x is 10, and y is 25. Okay, so we're going to go back to our derivative, right? Remember, we're after dx dt, and we're going to plug all those values in to the appropriate spots. X is 10, we plug that in here. Dy dt is 2, we plug that in here. Y is 25, we plug that in here. X is 10, we plug that in here. Dy dt is 2, we plug that in here. And so now we just have a lot of simplifying to do on either side of the equation. Over here, 2 times 10 is 20. Here I have 25 dx dt, and then 10 times 2 is 20 over here. Next up, I'm going to distribute this 1/2 through the parentheses. So 1/2 times 25 is 25 halves. 1/2 times 20 is 10. Okay, and now the equation is simplified as I can get it on either side. So now I'm going to try and get all the dx dt's on one side and all the terms without dx dt on the other side. So subtract 2 from both sides. That will give me an 8 over here. And then I am going to subtract 25 halves from both sides and get a common denominator. 20 is 40 halves minus 25 halves will give me 15 halves dx dt equals 8. And then finally I am just going to multiply both sides by 2/15. Over here that will make this a 1 over here, and then on the right side I have 8 times 2/15, which comes out to be 16/15. Okay, and so that's the answer for this one. Again, the related rate problems pretty much follow this exact same pattern. The ones that are related to physical situations are more complicated because you actually have to do the translation from the physical problem, right, to the mathematical equations and so on and so forth. So